So look at question 11 and 12, ratios of amounts. So tricky blue style questions. The three angles of a triangle are in the ratio 1 to 2 to 3. What's the magnitude of each angle? So magnitude means what's the size of each angle. So a triangle, does anyone know how many degrees would be in a triangle?
It's 180, I think.
Is that 180?
180 degrees.
180 degrees in a triangle, yeah. So this angle plus this angle plus this angle are 180 degrees. So the total, in other words, and we'll get onto this later in the year, this you may remember from year 6, the total is 180 degrees. And this has to be split up in the ratio 1 to 2 to 3. So if you split something in a ratio, that means you need to know the total parts. The total parts in this case, well, is 1 plus 2 plus 3, which is 6 total parts. So what's one part then? Well, it'd be 180 divided by 6 to give what one part is. So 180 divided by 6 gives 30. So that's one part. Now, if one part is 30, two parts would be 60, three parts would be 90. So that is your ratio, 30 to 60 to 90. So multiplying by 1, 2, and 3. So all about getting what one part is. That is question 11's answer. Question 12 works off a quadrilateral. So if you don't know what a quadrilateral is, we'll also do that later on in the year, so don't worry too much about it. But a quadrilateral is any four-sided shape. So it doesn't necessarily have to be a square. So four-sided straight-lined shape. Now the thing about a quadrilateral is, once again, we need to know about the angles. These corner angles here. What do they add up to? Well,
is the total angles of a quadrilateral, it's always 360,
360
right?
degrees is the total. How do I know that? Well, if you think about it, a quadrilateral can always be split up into two triangles. No matter what quadrilateral we draw, always two triangles if you split them up. And we don't know that one triangle is 180 degrees. So each one of these is 180 degrees in its corner. So if we add the other one, the total must be 180 plus 180, which is 360 in total. And that was a key to starting this. You could have researched that to find out what's the angles in a quadrilateral. So remember, these are the blue questions. So most of you guys didn't quite get around to doing them. But anyway, let's get the ratio 2 to 3 to 4 to 6. So that's our ratio here. That means I need to know my total parts again. Same as the other question. Total parts, 6 plus 4 is 10. Plus 3 is 13, plus 2 is 15. So there's 15 parts in this one. That means this 360 must be broken down into 15 parts by dividing by 15. 15 into 360.
24.
24 is it? Thank you. 24, yeah, 24. So 24 is one part. One part only. But I need 2 parts, 3 parts, 4 parts, 6 parts. So you can multiply by 2 to get 2 parts, that's 48. Multiply by 3 to get what 3 parts are, that's 72. Multiply by 4 then is add another, so that's 96. And then multiply by 6, and I get 4 and 6, 12, and 2, 144. And that is the answer to that. Okay, so that is the answer to the 2 hardest blue questions in ratios of amounts. If you're not hearing this or can't follow it or your Wi-Fi is not good enough, I'll post the video up on YouTube later on. Okay, let's move along.
Me?
Yes?
The answer for 12 was, I think it was the difference between the smallest and largest.
Oh, I didn't finish the question. What's the difference? Oh, I worked out all. I just presumed. I just read the question. Okay, what's the difference between smallest and largest? Well, that's 144 take away 48. And that's going to be 96, I think. 96 degrees. So this is the smallest. This is the largest. Okay, 96. All right, so let's move along. Let's look at the What's the next one we're looking at? Sorry for the delay. Year 7. For simplifying ratios, I'm going to do some of the yellow, and I'm going to do 2 examples, one from yellow, one from blue for this, and then I'll let you guys correct it in a minute. So this is from simplifying ratios, the homework. Okay, so the question from yellow is going to be question 7, and I'm going to do part F, 7F on that screen. So hopefully you see that. And if you're not seeing it, it's 0.375 to 0.8, and we're needing to simplify this. So this is from the yellow homework. Okay, so if I'm left with 2 decimals, 375 to 0.8. Well, I need to get these into whole numbers. There is a way of doing it without whole numbers, but I'm interested in getting these into whole numbers. There's 3 places after the decimal place here. So if I multiply that by 1,000, that will get rid of those 3 decimal places. So that's just 375. Now, it's not okay that I multiply just one side of the ratio. I must multiply both sides of the ratio by 1,000. So 0.8 by 1,000 gives me, remove this 3 places, boom, 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 and I'm left with 800. Now that's an easier starting point. So I'm going to divide by 5 maybe, and divide by 5. That's a definite one that goes into both these because it ends in 5 and 0. 5 into 3 doesn't go. 5 into 3, 7 does go.
Excuse me, Mr. Collins?
Yes, Rennie?
There was no question 7 in yellow. The first question was like the one about school, and you had to find the ratios of that.
No, if you scroll down, the yellow had a little bit on the next page.
Okay.
It's okay. You can, if you missed it, you missed it. No big deal. Okay, so dividing both sides by 5 gets us 75 to 160. I notice I can divide by 5 again. So 75 divided by 5 is 15. 160 divided by 5 is 32. Can it be divided again? 15, 32. I don't think it can be divided any further. 3 goes in here, but doesn't go in there. I don't think there's any common factor. So this is our final answer for that one in yellow. It's also a question. It was also a question in blue. I'm going to do one more of these. I'm going to do something from blue. I'm going to do question 6. And the part I wanted to do was part K, which was the ratio 1 to 1 3/5. Okay, so I want to simplify that down. I need whole numbers. Can't have fractions. How do I convert these so they are comparable, maybe using fractions? Well, I got to use, well, let's change this to an improper fraction. Maybe that. So it's 1. Let's start with that. Change this to an improper fraction. So how many fifths are in 1? Well, there's 5 fifths in 1. Add it to here and I get 8 fifths. Okay. Now I know 1 itself is 5 fifths. So I can change that to 5 fifths. 1 is 5 fifths. And now I have a common denominator, fifths. So that means the top parts can be compared. 5 to 8. So 8 parts to 5 parts, and that is it. Simplified fully. I have whole numbers, and it is simplified. Sorry, I have off screen a little bit there. Okay. I'll put the answers to that up on screen in the middle in a minute. I just want to look at the other and final worksheet now and do a couple of questions from that. And that was on the comparing ratios from yesterday. Once again, I'm going to look at some, I'm going to pick one from each. I'm going to do a green, I'm going to do a yellow, and I'm going to do a blue. Okay, so from green, for this one, I'm just going to look at part H. So that was question 1H. And it was comparing 5 to 6 and 7 to 8. So which one is the greater ratio of these pairs? Now, there's a number of different methods we can compare. We can use fractions, we can use cross multiplication, we can use decimals, and they'll all say the same thing. They're all going to say which one is bigger. You can kind of maybe guess which one is bigger out of these two. Is 5/6 of a pizza bigger than 7/8 of a pizza? I'd probably go for 7/8, but let's see. Let's get them as decimals. Let's see, do they compare as decimals? Okay, so I'm using my fancy calculator here. 5 divided by 6 as a decimal is 0.8. So 5 divided by 6 on the calculator, 6 will give you 0.833 recurring, so a little dot for recurring. 7 divided by 8, well, maybe I know that one off by heart, but it's 0.875. 0.875. So which is bigger? 7/8. Now, that's one method. Another method is compare them as fractions. 5/6. Yeah. So I'm just showing you multiple methods of 5/6 and 7/8. So now they're fractions. Now I'll only be able to compare if they are in the same denominator. So what common denominator will I use? I'll use, well, they both divide into 24. So I'll use 24. Because 6 times 4 is 24, so I multiply the top by 4. So 4 over 4 means it's equivalent if I multiply by the same number above and below, it's equivalent. So it's 20. That's the same as that. This 8 times 3 is 24, so if I multiply it by 3 on top, I haven't changed, and that's 21. So now they are comparable, which means this one is bigger. 21 over 24 is definitely bigger, and that's the same thing. The 7/8 is definitely bigger. And this whole right-hand side is definitely bigger, which means the initial ratio, I could have used either method, the fractions method or the decimal method, and a 7/8 is the bigger one. So good work if you got that one correct. You could also have used the cross multiplication method, which just compares numerators. So you do 5 times 8 is 40 and 6 times 7 is 42. So this time this side is bigger. Sometimes that can be confusing. So just these are two main methods. The question I'm going to do from yellow, and once again, I'll give you all the answers to these in a minute. The question I'm going to do for yellow is going to use one of the gradient questions. So I'm going to do question 4, part 4. So it was a triangle like this, something like that, only 7 meters long and 1.5 meters high. And they're asking to find out, well, they asked to find the gradients of them all, really, and then find out which was the largest and which is the smallest. So I'll just get the gradient of this, which will be the rise, how high it is, over how far across it goes. Or what they say is the rise over the run. Okay, so that'll be 1.5 over 7, or as a ratio 1.5 to 7, like dot 7. So it's the same thing. Fractions and ratios are interlinked. So what is that then? Well, I can change that to a decimal, or I can put it as a whole number ratio, which I might need to do. How do I convert this to a whole number ratio?
Times it by 2.
If I times it by 2, it'll work. If I times it by 10, it would work. Let's do it by 10 and then simplify it. I think times it by 10 gives me 15 to 70. And then I'll divide by 5, which is the same thing as multiplying by 2. If I multiply something by 10 and divide by 5. So 5 into that goes 3 times, 5 into that goes 14 times. And that's my ratio. That's my ratio. That's my steepness. It's 3 over 14 or 3 to 14. And that's my steepness for that one. Which is, then you could compare it to the other ones. I think this is the least gradient, the smallest gradient of the lot. I think the highest gradient was part A, which had a gradient of 1 to 1.
I got my answer right, but it's wrong. It's fraction. If I simplify that, 2 2 5. Wait, 2 2 2.
Fair question.
Over 1.
Frankie, you're unmuted if you didn't know.
Yeah, I have a question.
Yes, what's the question?
For this one, is it okay if we just did all the calculations with 1.5 over 7 and then multiplied it by 10 afterwards?
Yeah, it should be okay if you definitely didn't leave it as that as your answer. 'Cause a decimal within a fraction is technically not a great mathematical way of writing something. It's you'll be able to figure it out, but it has to be whole numbers in fractions. Otherwise, it's not really a fraction anymore.
I did, yeah.
Fraction
Yes,
has to
thank
be
you.
whole numbers. Okay.
Excuse me.
Yes, Rani?
I had a question for the question 5 on the ratio of amounts for yellow.
Yeah.
The 60% blue metal making concrete. I wanted to know, do we have to put our answer like as a decimal, or is it alright as a decimal, or do we have to round it to a whole number?
For the ratios, they
Yeah.
should all be whole numbers.
Oh, okay.
Okay.
But is it alright if our answer is in a decimal?
I
Like we
doubt
did
it, 'cause
0.5.
people. The answer was in people. I'll look at that at the end, maybe when I've gone through these, and then I can let other people go, and I can answer that question. But I think whole numbers. There should be no decimals in a final answer to a ratio.
Okay, thanks.
Okay.
I'm still a bit confused on that, sorry.
That's all right. I'll come back to that in a second. Let's just get my blue question done from this one, and I'm going to look at the drawing of triangles. So hopefully, this wasn't too difficult for a blue level question. The draw a triangle is the demonstrated gradient. So the gradient, or often called the slope, I'm going to do part E, is 2 over 5. How do I draw a triangle like that? Or a triangle to demonstrate that gradient of that. So remember, it will go up for every 5 it goes across. So it's up and across. So 2 units up and 5 units across. So something like that, you draw it out maybe 5 centimeters to 2 centimeters. And then to complete the triangle, you would just join the corners like so. If I wanted to do one like part D of 3 over 2, that means it goes up 3 and across 2. So that's going to be a steeper slope if you think about it. It's going up 3 for every 2 it goes across. So that's going to be harder to climb. If you're climbing this one, oh, that'd be tougher than climbing this one. So therefore, it is a bigger ratio than this one, which was 2 to 5, and this was 3 to 2. And of course, 3 over 2 is a bigger fraction than 2 over 5. All right. So the rest of them is going to be, the answers are on ManageBack. I'm just going to stop recording for a minute and then answer some questions.